I want to look at conic sections in polar geometry, and to begin with I want to look at a comparison between the polar point and the rectangular point. In a polar point we have two terms that define the point. We have a radius and an angle. In rectangular points we have an x and a y. So the radius is a distance from the polar center of our graph, and then this is an angle that's rotated counterclockwise from the polar axis, which is what over here in the rectangular coordinate system we would consider the positive x-axis. These points are showing distance in the x direction and the y direction from the origin, which is the intersection of these two axes. There's a way to convert between the two geometries, and that conversion is given with sine and cosine. X is r times cosine theta, and y is r times sine theta. So we can use this as a conversion. So we see that the x and the cosine are associated together, and the y and the sine are associated together. So an important idea with conics is eccentricity. If you think about eccentricity as a word, it's a deviation from an expected normal. In mathematics, it's a deviation from a circle. So the eccentricity for a circle is 0. And the eccentricity for an ellipse is somewhere between 0 and 1, but not including 0 or 1. If you're exactly equal to 1, then you are a parabola. And then if you're anything bigger than 1, you're going to be a hyperbola. So these are really important associations to know, the eccentricity and what kind of a curve to expect. Now I want to look at the standard form for an equation for a conic in polar geometry. We're going to have r equals e times d in the numerator and 1 plus e times cosine theta in the denominator. All right? And to know what the eccentricity is based on this formula, you're going to take the absolute value of e, and that's going to be your eccentricity. And then your directrix is going to be x equals d in this case. So there's a couple of variations that you see with this. Sometimes you see a negative here, and sometimes you see a sign here. If you see a sign here, your directrix is going to be y equals d. So you're going along the other way. And if you look back at this conversion, cosine is associated with an x, sine is associated with a y. That's a good way to kind of help you figure out when you're looking at a form like this, do you want your directrix in the x or the y direction? So this directrix is intercepting the x-axis. With sine in here, we would be intercepting what would be the y-axis if we were in rectangular coordinates. So that's an important thing to know. So the e in here is going to give us the eccentricity if we take the absolute value of it. And then the directrix will be determined from the d here. That d will be the intersection with an x or a y. All right, I want to look at this example, and I want to determine the eccentricity, the equation for the directrix, and what type of a conic this is. So the first thing that I want to do is I want to move it around so that I have this standard form. So by the commutative property, I'm going to move this -2 over here to the left. Okay, so when I move this -2 over to the left of the cosine, I'm going to add the addition sign in here so we know that the -2 is being added to this. So now in the standard form I have a 1 here. I want to divide everything by -2. -2 divided by -2 gives me 1, and so if I divide here I have to divide this term and this term also. So I'm going to have -16 divided by -2 will give me 8. -2 divided by -2 is +1, and then 4 divided by -2 is -2. So this is equivalent to this, which is equivalent to this. I'm just using some algebra to change the form. Now that I have this, I want to determine the eccentricity. And so I want the absolute value of E. And we see that E is this term here, and we have a plus here, so we have a -2 here. So I'm looking at the absolute value of -2 is 2, so the eccentricity is 2. All right, eccentricity of 2, 2 is greater than 1, so we have the hyperbola. And now I want to find the equation for the directrix. So we're at cosine, so we have x equals something. So I'm going to pull this 8 over to the side. 8 is equal to E times D. And E down here was -2. So I want to solve this. So I'm going to divide both sides by -2. So I'm going to get -4 equals D. And according to this up here, we're going to have x equals d. So the directrix is going to occur at x equals -4. All right, so we have the eccentricity, we've identified the conic, and we've identified the equation for the directrix. All right, one more example. I have r equals 9 divided by 3 plus 2 sine theta. First thing I want to do is get a 1 in this first position, so I'm going to divide everything by 3. So 9 divided by 3 is 3, 3 divided by 3 is 1, 2 divided by 3 is 2/3. And I've identified that this first term is e. I have a positive here. I want the absolute value of 2/3. That's going to be 2/3. So I have an eccentricity of 2/3. And 2/3 is between 0 and 1. So I have an ellipse. And now I need to identify the equation for the directrix. So I have 3 up here, and that's equal to ED. E was 2/3, so I have 3 equals 2/3 times D. If I multiply both sides by the reciprocal, I have 3/2 times 3 equals D, and that's going to give me 9/2 equals D. Now, since I have a sine here, sine is associated with a y-coordinate. I'm going to have y equals 9/2 as my directrix. So my directrix, my eccentricity, and my ellipse.